Hey guys, let's take a look at this is the 10th question in the 4.5 section where we're supposed to be working with exponential and logarithmic equations. We're given a problem similar to the log base 13 of x plus the log base 13 of 12x minus 1 is equal to 1. Now, the first step of their question asks us to rewrite the given equation without logarithms. Okay, so notice what I've done here. I took the equation that they gave me, set it equal to 1, of course, since theirs was equal to 1. To rewrite this without logarithms, the first thing you had to do was condense these two logarithms to 1. Anytime you have an addition sign between two logarithms, we know that we can combine that as one logarithm of the product of the terms within the logarithms. So I have the log base 13 of x times 12x minus 1. Now, I need to get rid of that log base 13. The way I do that is I do the inverse of a log base 13 to both sides of the equation, which means we need to exponentiate with an exponential base of 13 on both sides. So both sides of my equation goes up into the exponent of a 13. On the left-hand side, even though it looks difficult, it's not, because exponential base 13, log base 13, inverse functions, they cancel. You're just left with what's on the inside. And I went ahead and distributed the x to get 12x squared minus x. The right-hand side was that 13 to the first, which is obviously 13. Now, that's the first step of the answer here. It says rewrite the given equation without logarithms. Okay, so that was our 12x raised to the second. And then we had minus x set equal to 13. Done. I'll check that answer, and it's saying yes. Second part, now it's wanting us to solve that equation. And so when I'm thinking about the solution to the equation, I come in here and I say, well, all right, in order to solve that, I'm going to bring the 13 over to the left-hand side and set it equal to 0. When I brought that 13 over, I quickly looked at that and said, yeah, it's probably not going to factor very easily. So I went ahead and just chickened out and used the quadratic formula. Your options here would have been graphical analysis, although they wanted an exact answer, so graphing's probably not too good. You could have used completing the square, but that would have taken longer. Quadratic formula is the quickest method. So I went ahead and said x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, a is the coefficient of x squared, b is the coefficient of x, and c is the constant. So now when I say negative b, that gives me a positive 1 plus or minus the square root of b squared, which is just going to be positive 1, minus 4ac. Well, I notice minus 4 times 12 times negative 13. If you subtract a negative, you might as well be adding a positive. 4 times 12 times 13 gave me 624. I added 1 to that to get 625. Now that 625 is a perfect square, it's 25 squared, so the square root of 625 just gave me 25 in the next step. And I know my solutions are 1 plus 25 over 2, or over 24, which gave me 26 over 24, and that reduced down to 13 over 12. Now, you might also have to consider the solution 1 minus that square root, which is 1 minus 25. That gave me negative 24 divided by the denominator 24, and that reduced down to negative 1. Now, you instantly need to be highly suspicious of any negative answer you get in a logarithmic equation, because we know that the term inside of a logarithm can never, ever be 0, and it certainly can't be negative. So when you try to plug this 1 back into the problem, you'd say, yep, that's going to cause a negative there. So instantly, you'd just say x cannot equal negative 1. That is an extraneous solution, a solution that you get that is not part of the domain of the problem. So nothing algebraically wrong with that other than just the function doesn't exist at that value. So my only solution is 13 over 12. And 13 over 12 will certainly be a solution. We'll go back in here and plug that in. 13 over 12, whoops. 13 over 12. The other options were, there were infinitely many solutions. I can't imagine a problem that would have that as an answer. And there is no solution. That would be, what if both of these cause a domain restriction in your original function? That's possible, but this problem was not an example of that. It had the one solution, 13 over 12. We checked that answer, and it says nice work. Okay, that was my only question I had, so I'll stop here, but hopefully this helped out. Please let me know if you have any other questions. I'd be happy to help.